Okay, good evening, everyone. Thanks for coming here in that snowy evening. Today we are going to talk about machine learning and JavaScript. It's a topic that I think that we are going to hear much more about in the near future. But before we go deep into that topic, I'm going to take you on an historical tour. We started a historical tour 4 years ago. 4 years ago, is JavaScript a good language for machine learning? Node.js is designed for building network applications that really has nothing to do with machine learning. Can you do some machine learning in JavaScript if you really wanted? Sure, but that's like hitting nails with a screwdriver. It would just make your life a whole lot more difficult. That was written by a research engineer at Google DeepMind in 2015. Our historical tour continues 4 years before that. 2011, can we do JavaScript on the server side? Node.js is tumor on programming community, a scalability disaster waiting to happen. This is probably the worst thing that any server-side framework can do, be written in JavaScript. And that was written by a senior tech staff at eBay. I have to say that at the time you could find more quotes like that on the internet. Most of them have been erased by the users. And this quote itself I had to find on some mirror site because it was also erased from the original website. And we conclude our historical tour 4 years before 2011, in 2007. Anything that can be written in JavaScript will eventually be written in JavaScript. I'm sure you've seen that before. Written by Jeff Atwood, the co-founder of Stack Overflow, a prophecy that so far has been fulfilled. So now, back to the future. 2019, let's start. What is the state of the art of machine learning in terms of languages and frameworks today? Python is by far the dominant language. It is easy to prototype, and it is suitable for many machine learning applications. There are tons of resources. There are communities. This is like Googling machine learning books in Python. It's not the end of the list. And we have two very prominent frameworks that most people are using. TensorFlow by Google, with 47,000 commits on GitHub, 119,000 stars, and 1,800 contributors. PyTorch by Facebook is the second one. It has 15,000 commits, 24,000 stars, and 900 contributors. Python, as I said, is dominant on the machine learning front. But when it comes to do high-performance applications, think about self-driving cars, then C and C++ are the languages that come in hand and are used. So in fact, when Uber or other companies are building algorithms, machine learning algorithms for self-driving cars, the scientists will do the experiments and develop the algorithms in Python. Production will be done in C or C++. In the academic and in the data science communities, R, MATLAB, and Julia are popular languages, and I'm not going to go into that. There are debates, and you can find them all online. So what about JavaScript? What's the role of JavaScript? JavaScript for machine learning in 2019 has, first and foremost, tensorflow.js. This is Google's training and deploying machine learning models. It's good for the browser and for Node.js. And it's a library that was released in March 2018, so it's almost a year ago. It created a lot of hype and created a lot of interest in the JavaScript community in the area of machine learning. If you look at GitHub, 125 commits, 10,000 stars, and 32 contributors, you understand that this is still behind Python, and there is a long way to go. I'm going to go deeper into that and explain not just the difference in GitHub stats, but the differences in use cases and what you can do with the language. But before we do that, I just want to say that Google is by no means the only resource. There are tons of other resources about JavaScript and machine learning. This is just a GitHub web page that gives all resources about machine learning, and the list is very long. There are books about that, online resources. So let's dive in. Machine learning in JavaScript, why? The key feature, the key point about doing machine learning in JavaScript is the fact that it can run in the browser. I'm going to take a little pause before continuing to explore that point and explain the conceptual steps that you need for solving machine learning problems. I'm using here supervised learning. Supervised learning meaning learning from labeled examples, because that's the machine learning technique that today gets most of what's happening, most of the best results, the good results that you see in machine learning today are happening with supervised learning. So it's a good example. And there are 5 steps, 5 conceptual steps that you need to take in order to solve a problem. First, you need to understand what data is relevant for the problem in hand. Then you assemble data, you collect data that is relevant for your problem. And you need to decide on the type of output that you want to predict. Here we talk about 2 terms, classification versus regression. Classification being an output that is discrete, so is it true or false, is it red or blue, is it bucket 1 or bucket 2 or bucket 3? And regression being the prediction of a continuous value. Find me the right number on the scale between 0 and 100. Step number 4 and step number 5 are the crucial ones. Training. You pick an algorithm, and that algorithm has to determine a correlation between your input, often called features, and your output, the labels that you want to predict. Once you've done training, you have a model, and you can use the model that was generated by that algorithm that you chose in order to make a prediction. So now when we come to look at machine learning in the browser, we have to think about inference versus training. The big benefit of using machine learning in the browser is the fact that we don't need to send any data to the server. It's always available, it's always interactive, it's always real-time. You can be more cost-effective. You don't have to pay for sending data on your mobile data usage. And your data can remain private. Personal information, sensitive information can remain on your client device. You don't have to share it with the server. But the drawback is that machine learning training requires computational power, huge computational power, and large data sets, large data sets. And the client devices are just not powerful enough to deal with that and to do that. So the potential that the community sees in doing machine learning in the browser is, first of all, with doing inference, bringing machine learning computation, the inference, the prediction into the browser. And the second thing is doing simple training, but only simple training. Before I continue, the fun part is about to start now. We are going to look at the examples and the things that are being done with machine learning in the browser. But before I continue, think about the days of server-side rendering, when that was the only option, when there was no single-page application. Everything that you had to do had to go to the browser and come back as HTML. This is like the days of machine learning today in metaphor. Everything has to go to the server and get computed. Even if you want to say, Alexa, or OK Google, it goes to some server in the United States, it understands your voice, it comes back. You want to type something, the machine learning has to predict if you are typing, is it now category 1 or category 2? The drop-down has to populate with 3 options or with 5 options, and machine learning is involved. It's only the server that will do it today. And the big promise of machine learning in the browser is to replace that with computation that just happened there on your device. So one of the exciting things when you start looking at the actual applications, the actual examples and demos of doing machine learning in the browser is the easy access to all the sensors. You get immediate access to the data from your camera, from your microphone, and all other sensors. Photos, videos, can be immediately processed. This is a great example. I might jump into it at the end of the presentation to just show you how it works because it's so much fun. But you train your own photo according to 3 colors. You train the green, the purple, and the orange. And every one of those categories, so this is a classification problem. It's a discrete classification. Will produce either a picture or a sound or speech. And then magic happens. You can play the bass. You can play the drums. Or you can play the guitar. And the machine just gets it. This is without audio. I will try to get back to it and show you the audio and play with that. The moment those kind of things are possible, there are so many ideas for interactive gaming experience that can come to mind. For example, let's play Mortal Kombat with tensorflow.js. Train the computer to understand our punches and our kicks, and they are actually transferred into the image in the game. And the key point here, the key technique here, is the one that is called transfer learning. And this is what many of the machine learning models that are running in the browser actually use. We use an existing model, an existing neural network that was trained offline in the backend on the servers using a very, very large data set, and we can feed its output into a new neural network, into a new model that is trained in the browser using a very small and personalized data set. This part of the model, the big chunk here, cannot be trained on your device. It's too difficult, too CPU intensive. The data set that is needed cannot fit on your device. But you can get the model from the internet, and you can execute it. You can do inference with it in your device. And you can use it to train those last layers of your neural network that will just fit it to your images, to your last touches. And then this network becomes your own personal network. It actually gets only you. It can identify either your face or your movement or whatever you're trying to do. Now, if we allow easy access to sensors, and we start thinking about interactive gaming experiences, then we need to get into the game our web developers and our designers, because these are the creative people that are going to make all the magic and bring all the ideas. Machine learning, especially deep learning, has been an area that was very difficult to learn, very complex for any developer to get into. And nowadays, there are new types of wrappers around machine learning libraries like tensorflow.js that allow you to basically develop an approachable or friendly version of machine learning for the web. The code that does the style transfer that you see here using some cubism picture and transfer it on my own video, the code that does it is just written in that part of on the left part of the screen with ML5.js. And ML5.js gives you a list of many more examples that you can just apply like that. Image classifications, video classifications, text generations, and so forth. On the other hand, the same technique of visualization can be used in order to explain the difficulty, the complex of machine learning and deep learning to a much broader audience of people. There are tools that give you interactive visualization of deep learning, and they make neural networks much easier to learn. This tool, for example, and I'm going to jump for a second to the website, allows you to tinker with a neural network. When you develop neural networks, there are so many parameters that you can play with. You can play here with, well, first of all, the data that you want to classify, that's obvious. But then, which features are you going to choose? You can select different features. You can play with your neurons. You can add more layers. You can add more neurons to the layers. I'm not getting into the technicality of what it means. But at the end of the day, you just press a button here, and you see how it visualizes how your network just classifies the input data into oranges and blues in this example. And it allows you to play with your learning rate, with your activation function, and the rest of the parameters. This is a great tool to go and learn machine learning. And before we had machine learning in the browser, the only way to do that was like try to visualize it in your head, look at the mathematics, and try to get the hang of it. Next, and most important for the audience here, the developers, the developer experience. With machine learning in the browser, the developer's experience, the experience of developing machine learning modules and code becomes upgraded, becomes parse compared the same level as developing web applications with inspect and looking into your variables and debugging and everything that you know from opening a Chrome inspect page or any other of the browsers that you use. It's not that those things did not exist with Python, but it involved a lot of prints and a lot of plot functions. If any one of you did a tutorial in Python, especially the old ones, there was always this moment where you're supposed to run some kind of a plot to see the result of what you did. It is very much old-fashioned in the way web developers think about how they work with their software. The second problem, the Python community came up with, it's actually Google, came up with a tool called TensorBoard, which gives you incredible capabilities in terms of debugging and looking into what actually happens when you work with networks, with machine learning. But it's a tool that you have to install on your own device. If you want to share the results, if you work in a team and you need to collaborate, that's a problem. And there are people complaining about how to share those information. And now, if it's in the web, it's like any other web app that we use, whether it's Jira or GitHub or collaborative document and slide sharing. The last thing I want to mention about machine learning in the browser is the area of reinforcement learning. So this is different than supervised learning. Here we talk about environments that allow users, namely human users, to interact or to play with machine learning agents and teach them, train them how to take certain actions in order to maximize a certain reward. It's like playing a game against the machine, but the machine is learning while you're playing with it. And we are not talking just about games, we are talking about things like self-driving cars. So these are two examples of projects that today they are primarily educational, but there's a lot of potential in putting those reinforcement learning in some kind of a visualized interactive form on the web page and letting users give the machine the feedback that it needs and get it to a better learning stage. So what about the server? What about Node.js? Can we do machine learning in JavaScript in Node.js? Well, it's also on the server. Almost. It's work in progress. So I will just quickly explain. It's less exciting than the browser side. Tensorflow.js, the JavaScript library that was published by Google, supports Node.js. They have an NPM, and you can install NPM TensorFlow. And the exciting promise with TensorFlow.js in Node.js is the ability to port your TensorFlow models between Python and Node.js. So you can build a model in one of them and use it in the other one. The second exciting news is that the moment you have machine learning in Node.js, you can easily integrate it into Node.js stacks, namely existing ones. Because today, if you don't do that, you have to build your stack in Python or whatever language you choose. And if your full stack is JavaScript, this is another moving part in the ecosystem of your company. But it's not production ready yet. That's what Google says on its website. We are getting there. Google also publishes data about the performance of machine learning in JavaScript. What I show here is taken from videos, YouTube videos of Google from last year. They compare two things. They compare performance on the browser and performance on the server with Node.js. On the browsers for inference, for predicting results, they claim that tensorflow.js using WebGL, so using the GPUs on your computer, is 1.5 to 2 times slower than a comparable application that runs with Python. Training is 10 to 15 times slower than the comparable application that would do it with Python. On the server side, that was another presentation of Google a few months later. They came with the news that they were able to do inference in comparable times. So that's what we see on the right side. They were able to get Node.js and Python to run in comparable time for inference. They said nothing about training. So I think this is something to continue to follow. And I think that Google and probably others are putting a lot of effort in getting it into a better shape. And it will probably get better. I was talking about TensorFlow.js mostly. And the examples that I showed you were mainly wrappers or built on top of TensorFlow.js. But who else is in the game? Well, everybody. Microsoft, Facebook, and AWS, they joined forces to create the Open Neural Network Exchange, or ONNX. So that's an open standard for representing machine learning models. And the idea here is to try and break vendor lock. I can say it in different words, try and break TensorFlow's dominancy. But what they do is very nice, it's very promising, because they created interoperability across all AI frameworks. And essentially, what it allows you with the release of ONNX.js, which was released the very first version of it was just released in November last year, is to take any model from PyTorch or from CNTK, which is the Microsoft framework, or from TensorFlow, or from many other libraries, including MATLAB and anything that you can think of, and just export it into the ONNX format, and then send it to the browser and run it, inference. Or send it to Node.js and run it, again, inference. And they show very promising performance results with CPUs where they use WebAssembly, or with GPUs and WebGL. So this is all very new, and I think very much in its beginning, but good to follow. And there will probably be interesting developments on that front as well. If you want more, it doesn't end with the big guys. There are, and I don't know if it was since the release of TensorFlow.js, it seems some of those things started before. It definitely created much more hype. There are so more libraries that are written in JavaScript and allows you to run different types of neural networks and deep learning models. And they vary in the algorithms that they let you implement. They vary in the architecture of the network. If you remember the website I showed, like some of those models force you to build an architecture of your layers of the neurons up front. Some of them discover it on the way or allow you much more flexibility in the way your network is structured. This is just a list of some of the names that come up. I also added here a talk that I found and watched and very much enjoyed. It's a talk about deep learning in JS from last year, JSConf in Europe. The speaker is not a developer. It is not like very technical, but still it is very technical, and she manages to explain how deep learning works in a very intuitive and clear way. So that's really nice. It's not easy to do. And two last things are left before I finish. One, when I was researching a little bit the information for this talk, I found this blog post from 2016 and it was about the history of JavaScript across the stack. And the person who wrote the blog post put this very cool visualization of how JavaScript in 2016 is actually present in different places all over the stack. So here is my prediction for the future of JavaScript across the stack with machine learning. It will look something like that. And before I end, I promised you to try and play with Teachable Machine. Remember the website? Let's see if we can do it. We are choosing sound. We are choosing bass here. We are choosing guitar here. We are choosing drums here. Now we try to teach the computer to do things. Let's put on, let's see that we have some volume. Should have volume. Okay. That was the bass. See the images that are taken? It just takes like 60, 70, 100 images. This is the only state that it knows now. Whatever I do, it's going to do bass. I can do that, or that, doesn't matter. Now let's teach it the second state, the guitar one. That will be the guitar. It collects examples, and we are playing guitar. Now let's see. And the drums now. Okay, it's about 100 pictures of drums, and we are good to go. Okay. Thank you, guys.